Welcome to Ultimate Sleep Doctor. Tonight, we'll delve into a realm of profound wonder, the mind. It's a universe within us, a landscape built of electrical impulses, of memories, and of dreams. A space where thoughts blossom and fade like wildflowers in the breeze. This intricate system, so complex yet so fundamentally connected to our being, continues to fascinate scientists and inspire awe. Consider the quiet stillness of a clear night, the vastness of the stars reflecting in your own awareness. There's a beautiful harmony between our inner worlds and the outer ones, a delicate balance we're about to explore. If you find these explorations soothing, please consider liking this video and subscribing to Ultimate Sleep Doctor. Together, we can soothe more wandering minds, one peaceful night at a time. Just breathe, let your thoughts drift, allow yourself to settle into comfort. Let's begin. The brain, a truly incredible organ, isn't a static, fixed thing. It's far more like a living, breathing city, constantly being built, remodeled, and rerouted. For a long time, scientists believed the brain was largely formed in childhood, that after a certain age, it simply stopped changing. But we now know this isn't true at all. The brain possesses a remarkable ability called neuroplasticity, a fancy word that simply means it can reorganize itself by forming new neural connections throughout your entire life. This ability stems from something called neurons, the fundamental building blocks of our nervous system. Each neuron is like a tiny messenger, capable of sending electrical and chemical signals to other neurons. Initially, when we learn something new, these connections between neurons are weak and inefficient. Think of it like a newly paved road. It's rough and bumpy, not yet smooth and easy to travel. As we repeatedly practice a skill, playing a musical instrument, learning a language, even simply remembering a route, these connections strengthen. The neurons that are firing together become more likely to fire together in the future. It's a process called neurons that fire together, wire together, a phrase coined by neuroscientist Donald Hebb. The more frequently a specific pathway is used, the thicker and more efficient that pathway becomes. This makes it easier and faster for your brain to perform that task. But neuroplasticity isn't just about learning new things. It's also at work when we experience something unexpected or challenging. For example, if you break your arm, your brain doesn't just accept the injury. Instead, it begins to rewire itself, creating new pathways to compensate for the lost movement. This is partly why physical therapy after an injury is so crucial. It actively encourages these new connections to form, helping you regain function. Furthermore, neuroplasticity demonstrates itself in ways that are often subtle and surprising. Studies have shown that people who learn a second language often exhibit enhanced cognitive abilities, like improved problem-solving and multitasking skills. This isn't because the second language itself is inherently better, but because the brain has been forced to create entirely new pathways and connections to process information in a different way. It's not just about large-scale changes either. At a smaller level, neuroplasticity happens constantly, refining the connections within your brain even as you simply think and feel. The more you focus on one idea, the more robust that neural network becomes. Conversely, if you stop using a particular skill or pathway, it can actually weaken and eventually fade away, a phenomenon called use it or lose it. This inherent adaptability means your brain isn't a rigid container, but a dynamic, ever-evolving landscape. It's a testament to the incredible resilience and potential residing within you, reminding us that we have a powerful influence over the very structure of our minds. And as you drift off to sleep, your own brain is quietly, persistently reshaping itself, preparing for new experiences and learning tomorrow. As our brains continue to build connections, a fascinating and somewhat mysterious process unfolds, particularly when we're not actively focused on the outside world. Scientists have identified a specific network of brain regions that seems to hum quietly beneath the surface of our conscious experience. It's called the default mode network, or DMN. Think of it as a sort of internal workspace that's most active when we're not actively doing anything in particular. It's not default in a bad way. It's simply the state the brain slips into when it's not busy processing external stimuli like a roaring train or a demanding task. The DMN isn't just idling, though. When it's engaged, it's involved in a remarkable kind of thinking, a thinking about thinking itself. The core regions involved include the medial prefrontal cortex, which is involved in self-reflection, and the posterior cingulate cortex, which plays a crucial role in integrating information and searching for patterns. The angular gyrus, responsible for processing language and understanding abstract concepts, is also frequently part of this network. These areas seem to be most active when we're daydreaming, reminiscing, or simply letting our minds wander. A key function of the DMN is what researchers call self-referential thought. This means we're engaging in thoughts that are primarily about ourselves, our past, our future, our relationships, and even our own sense of identity. It's when we might find ourselves suddenly pondering what we did wrong in a conversation, anticipating a future event, or reviewing a cherished memory. The DMN provides the space for these kinds of reflections to occur, constructing a narrative of me that shapes our understanding of the world. It's not just a passive process of remembering, it's an active construction of a personal story. Interestingly, the activity levels of the DMN tend to decrease when we're fully engaged in a task, like solving a puzzle or reading a book. This suggests that the DMN is essentially switched off when our attention is directed outwards. However, even during focused activities, the DMN continues to operate, though at a lower volume, potentially shaping our interpretations and providing a background context for our experiences. Research has revealed connections between the DMN and autobiographical memory, those deeply personal recollections that form the foundation of our identity. The network seems to be essential for retrieving and integrating these memories, allowing us to draw upon past experiences to inform our present actions and anticipate future possibilities. Furthermore, studies have shown that the DMN's activity is linked to empathy, allowing us to simulate the experiences and perspectives of others, though the precise nature of this relationship is still being explored. The DMN truly represents a complex and vital part of how the brain maintains a sense of self and engages with the world around us. A silent, internal landscape constantly shaping our thoughts and feelings. Deep within the brain, tucked away in areas normally associated with movement, lies a remarkable discovery that has fundamentally shifted our understanding of how we connect with others. It began with researchers studying macaque monkeys, observing them performing simple actions like grasping a peanut or grooming another monkey. What they found was astonishing. Certain brain areas fired not just when the monkey performed the action, but also when they observed another monkey doing the same thing. These neurons weren't simply recording the action. They seemed to be mirroring it, as if the observing monkey was experiencing the action itself. These were the first identified mirror neurons. Scientists later found evidence of them in humans, though the exact extent and function remained a mystery for many years. The core principle is this: when we witness someone else's action, a specific pattern of neural activity arises within our own brains, mirroring the activity that would occur if we were carrying out that same action. It's as if our brains are building a miniature, internal simulation of what we're seeing. This isn't about consciously deciding to feel empathy. It's a foundational neurological process that happens automatically. The implication of mirror neurons goes far beyond simply copying movements. Researchers hypothesized that they are the biological basis for understanding the intentions and emotions behind those movements. When you see someone stumble, your mirror neurons fire as if you were stumbling yourself, allowing you to instinctively grasp the potential for difficulty or pain. Similarly, observing a smile triggers a mirroring activity in regions associated with reward and pleasure, contributing to our own feelings of happiness. Crucially, the discovery of mirror neurons offers a potential explanation for the origins of empathy. Prior to this finding, the roots of empathy were largely debated, with theories relying heavily on conscious reasoning and learned behavior. But mirror neurons suggest a more fundamental, embodied basis. The ability to feel what others feel, at least in its most basic form, may originate from this intrinsic mirroring mechanism. It's not just about recognizing that someone is sad. It's about experiencing a faint echo of that sadness within your own nervous system. Studies have demonstrated a correlation between the density and activity of mirror neurons and an individual's capacity for empathy. Individuals with more active mirror neuron systems appear to have a heightened ability to intuitively understand and respond to the emotions of others. Furthermore, research is exploring how disruptions in mirror neuron activity might be linked to conditions like autism spectrum disorder, where difficulties with social interaction and emotional understanding are often observed. It's important to note that mirror neurons don't solely determine our empathetic responses. Higher-level cognitive processes, such as social awareness and conscious reflection, certainly play a vital role. However, the mirror neuron system provides a foundational neurological architecture upon which empathy is built, a silent, automatic connection forged within the very fabric of our brains. It's a testament to the incredibly intricate and interconnected nature of the human mind, constantly seeking to understand and relate to the world around us. The day's experiences leave a trace, a scattering of electrical activity within the brain, representing the new pathways forged during learning. It's like a draft of a story, interesting, perhaps, but fleeting and vulnerable. Much of this initial learning, a temporary strengthening of connections, fades away within a few hours if left unattended. But the brain possesses a remarkable mechanism for ensuring that truly important information isn't lost. This process is largely driven by sleep, and it's particularly potent during the early stages of sleep, specifically slow-wave sleep. During slow-wave sleep, the brain's electrical activity becomes incredibly slow and synchronized, like a vast, rhythmic ocean. This deep, restorative sleep creates an environment perfectly suited for the replay and strengthening of memories. It's not just a passive state of rest. The brain is actively working to transform fragile, newly formed memories into something more durable. Scientists have identified specific brain regions involved in this consolidation process. The hippocampus, initially crucial for forming new memories, begins to tease out the details of the experience and gradually transfer them to the neocortex, the part of the brain responsible for long-term storage. Think of it like sorting through a pile of documents, initially scattered and disorganized, and systematically filing them away in a structured archive. During sleep, the hippocampus repeatedly reactivates the neural patterns associated with a learned event. This reactivation isn't simply a passive replay. The brain is actively reinforcing the connections between neurons that were involved in that learning. It's like running a simulation, strengthening the pathways with each iteration. Simultaneously, the neocortex begins to create its own, more stable representation of the memory, independent of the hippocampus. The strength of these newly established connections is increased through a process called long-term potentiation. Essentially, the synapses, the junctions between neurons, become more efficient at transmitting signals. This heightened efficiency is what makes the memory more resistant to disruption. Conversely, synapses that aren't consistently reactivated during sleep weaken and eventually fade away, a process known as synaptic pruning. Different types of memories are consolidated in different ways during sleep. Procedural memories, like learning to ride a bike, rely heavily on slow-wave sleep for consolidation, whereas declarative memories, facts, and events show increased consolidation during REM sleep, the stage characterized by vivid dreaming. It's believed that REM sleep plays a crucial role in integrating new declarative memories with existing knowledge. Furthermore, research suggests that sleep deprivation severely impairs this consolidation process. When we don't get enough sleep, the brain simply doesn't have the time to properly reinforce these memories, leading to difficulty recalling information learned during the day. It's as if the archivists have been rushed and the documents haven't been properly filed. The intricate interplay between sleep stages and memory consolidation highlights the brain's elegant design, a constant, silent effort to transform fleeting experiences into the bedrock of our knowledge and understanding. Deep within our bodies, a secret conversation is constantly unfolding, a dialogue that profoundly impacts how we feel, think, and even behave. This isn't a conversation between our organs, but one involving trillions of tiny inhabitants, the microbes that make up our gut microbiota. These aren't just random hangers-on, they're an intricate community, and their influence extends far beyond digestion, reaching all the way to the mind. Scientists now recognize a remarkable connection, a bidirectional pathway they call the gut-brain axis. It's a complex system where the gut and the brain constantly communicate, influencing each other in fascinating ways. These microbes, including bacteria, fungi, and viruses, play a vital role in breaking down complex carbohydrates we can't digest ourselves, creating beneficial short-chain fatty acids like butyrate. But their impact goes much deeper. They help train and regulate our immune system, a system that's intimately linked to mental health. An overactive or imbalanced immune system, often triggered by gut dysbiosis, an imbalance in the microbial community, can contribute to inflammation throughout the body, and importantly, in the brain. This chronic inflammation is increasingly recognized as a significant player in conditions like depression and anxiety. Furthermore, the gut microbiota directly impacts neurotransmitter production. Neurotransmitters like serotonin, dopamine, and GABA, chemicals crucial for mood regulation and happiness, aren't solely manufactured in the brain. A considerable amount is actually produced in the gut by the microbes, acting as a key regulator of these vital signaling systems. Specific bacterial strains have been shown to actively stimulate serotonin production, for example, while others can inhibit the production of inflammatory compounds. The communication pathways aren't just one way. Signals travel both ways along the gut-brain axis. The vagus nerve, a major nerve connecting the gut and the brain, acts as a crucial communication line, transmitting information in both directions. The gut microbes can influence vagal nerve activity, triggering responses in the brain related to stress, mood, and even appetite. They can also send signals through the immune system, activating pathways that affect brain function. Emerging research is exploring how manipulating the gut microbiota through diet, probiotics, or even fecal microbiota transplantation can potentially influence mental health. For example, certain probiotic strains have demonstrated promising results in reducing anxiety symptoms in some individuals. Scientists are now investigating whether restoring a healthy balance of gut microbes can alleviate symptoms and perhaps even offer a new approach to treating mental disorders. This isn't about a quick fix, but understanding and nurturing this intricate connection. It's a reminder that our mental well-being is inextricably linked to the health of the tiny world residing within us. The human brain is a remarkable thing, constantly interpreting the world around us, and often it's not interpreting reality as it actually is. This is where the placebo effect comes into play, a truly fascinating phenomenon where a person's belief in a treatment, even if it's inactive, can trigger a genuine physiological response. It's not simply about wanting to feel better. The very act of expecting improvement fundamentally alters how the brain functions. Scientists have pinpointed specific areas involved. The anterior cingulate cortex, normally associated with pain processing and decision-making, becomes significantly activated during placebo treatments, even when the treatment itself offers no pain-relieving substance. Similarly, the periaqueductal gray, a region crucial for pain modulation, shows increased activity. These aren't just passive responses to a suggestion, they're active changes in brain circuitry. The key player, researchers believe, is a complex cascade of neurochemicals. When someone receives a placebo, perhaps a sugar pill, a saline injection, or even a sham acupuncture treatment, the expectation of benefit triggers the release of endorphins, the brain's natural painkillers. Endorphins effectively dampen the perception of pain signals traveling to the brain. Furthermore, the placebo effect activates the dopamine system, responsible for reward and motivation. This contributes to feelings of well-being and can even induce a mild euphoria. It's not just about pain, either. The placebo effect has been demonstrated in a wide array of conditions, including anxiety, depression, Parkinson's disease, and irritable bowel syndrome. In Parkinson's, for example, placebos have been shown to stimulate dopamine release in the brain, momentarily alleviating motor symptoms. This highlights the profound ability of the brain to mimic the effects of a genuine treatment through the power of expectation. What's truly astonishing is that the brain seems to learn to anticipate these changes. Repeated placebo treatments can actually strengthen the neural pathways involved in the response. This suggests a feedback loop. Belief leads to neurochemical changes, which in turn reinforce the belief, creating a self-sustaining cycle. The placebo effect isn't about tricking the patient. It's about acknowledging the intricate connection between the mind and the body. It demonstrates that our thoughts and beliefs are not just passive observers of our physical state, but active participants in shaping it. This understanding has significant implications for how we approach treatment, particularly in areas where the placebo effect is powerfully demonstrated. It reminds us that the brain is incredibly adaptable, and that our expectations can have a tangible impact on our health and well-being. The human mind possesses a remarkable flexibility, a capacity to shift its experience of reality beyond the everyday. This isn't about delusion, but about accessing different neural pathways and patterns of thought that are ordinarily dormant. Scientists have long been intrigued by ways to deliberately induce these altered states, and two prominent avenues of exploration have emerged: the study of psychedelics and the practice of meditation. Psychedelics, such as psilocybin found in magic mushrooms or LSD, offer a potent example of this shift. Research suggests these substances dramatically alter brain activity, particularly in the default mode network, a region normally associated with self-referential thought, rumination, and a sense of being a separate, observing entity. When taken in controlled settings, psychedelics can temporarily diminish this network's activity, leading to a profound sense of ego dissolution, where individuals report feeling deeply connected to everything around them, experiencing time differently, and encountering intense, vivid sensory perceptions. The precise mechanisms are still being investigated, but it's believed that psychedelics increase the synaptic plasticity, the brain's ability to form new connections across the entire brain. They essentially heighten the sensitivity of neurons, allowing for a richer and more diverse range of neural firing patterns. Importantly, this heightened plasticity isn't just a passive response. It appears to be actively shaped by the individual's intentions and focus during the experience, suggesting a powerful feedback loop between mind and brain. Some researchers hypothesize that psychedelics may also facilitate the formation of entirely new neural circuits, essentially rewiring the brain. Meditation, particularly mindfulness meditation, takes a different approach. Rather than dramatically altering brain chemistry, it involves training the mind to focus on a specific anchor, often the breath, and gently redirecting attention when it wanders. Over time, this practice sculpts the brain's neural architecture, strengthening connections associated with attention, focus, and emotional regulation. Neuroimaging studies reveal that regular meditators exhibit increased gray matter volume in areas like the prefrontal cortex, the region responsible for higher-order cognitive functions, and the insula, which plays a role in self-awareness and interoception, the sense of what's happening within your body. This isn't simply about emptying the mind, a concept often associated with meditation. Instead, it's about cultivating awareness of thoughts and sensations without judgment, developing a non-reactive relationship with experience. The consistent practice creates a neurological muscle for attention, making it easier to resist distractions and maintain a calm, centered state. Essentially, meditation fosters a new baseline for brain activity, a state of greater stability and resilience, which can have profound effects on mental well-being. Both psychedelics and meditation demonstrate the brain's astonishing capacity for adaptation and transformation. They highlight that consciousness isn't a fixed state, but a dynamic process, shaped by both internal experiences and external practices, offering exciting potential for understanding and ultimately improving the human condition. Our brains are incredible machines, constantly processing a staggering amount of information. But they don't operate with the meticulous precision of a supercomputer. Instead, they rely on a collection of mental shortcuts, known as cognitive biases and heuristics, to make decisions and interpret the world around us. These aren't necessarily flaws. In fact, they're incredibly efficient. They allow us to react quickly in situations where a full, logical analysis would take far too long. One of the most common is confirmation bias, the tendency to favor information that confirms our existing beliefs. Let's say you believe a particular political party is inherently corrupt. You'll likely notice and remember news stories highlighting scandals involving members of that party, while dismissing or downplaying evidence to the contrary. It's not that you're deliberately trying to be biased. Your brain is simply streamlining the process of information gathering, focusing on what already aligns with your viewpoint. Heuristics are even more fundamental. These are rules of thumb, mental strategies that we use to simplify complex problems. The availability heuristic, for instance, causes us to overestimate the likelihood of events that are easily recalled. If you recently heard about a shark attack, you might suddenly feel much more fearful of going swimming in the ocean, even though statistically, shark attacks are incredibly rare. The vividness of the news story significantly influences your perception of risk. Another influential heuristic is the representativeness heuristic. This describes how we judge the probability of something being true based on how similar it seems to something else. For example, if someone is quiet, enjoys reading, and is detail-oriented, we might incorrectly assume they are a librarian, even if the probability of them actually being a librarian is very low. It's about judging likelihood based on superficial resemblance, rather than actual statistical data. These biases and heuristics aren't always detrimental. They provide a crucial speed advantage in many situations, allowing us to navigate a world filled with uncertainty. However, they can also lead to systematic errors in judgment, influencing our choices in everything from investing decisions to interpersonal relationships. Researchers have demonstrated that even experts in various fields, doctors, lawyers, pilots, are susceptible to these cognitive traps. Interestingly, our emotional state can significantly amplify these effects. When we're feeling anxious or stressed, our brains tend to rely more heavily on heuristics, often leading to more impulsive and potentially irrational decisions. Similarly, strong emotional attachments can intensify confirmation bias, making us even more resistant to contradictory information. Understanding these cognitive biases and heuristics isn't about blaming ourselves for making mistakes. It's about becoming more aware of the subtle ways our minds are shaping our perceptions and judgments. By recognizing these patterns, we can consciously strive for more objective analysis, seeking out diverse perspectives and challenging our own assumptions, a continuous and remarkably rewarding journey of self-discovery. If you're still awake and enjoyed this exploration, please consider liking this video and subscribing to Ultimate Sleep Doctor. Together, we can soothe more wandering minds, one peaceful night at a time. We've journeyed through the intricate landscapes of the mind, discovering its quiet power and gentle rhythms. Now, let your thoughts drift, calm and unhurried, like clouds across a serene sky. Allow your awareness to soften, welcoming the embrace of sleep. Good night.